Okay, function notation, Unit 1, Lesson 2. So main idea is that we are dealing with functions with two variables. We want to be able to specify what the input is and what the output is. So for example, it says, let's say for part 2, let's say you were not given the value of the constant at all, but you were told length is a constant. Then A equals LW is a linear relationship, and the input is W and the output is A. And remember, a constant is a fixed value, is a number on its own, or sometimes a letter such as A, B, or C to stand for a fixed number. So when we're dealing with, especially situations where there are multiple letters, multiple variables, we want to be able to identify right away what is the input, what is the number that you're subbing in, or the expression that you're subbing in, and then what is the output. And so number 3, what is a function notations? It replaces the output y with name bracket input, and the whole thing is considered the output. So for example, f is the function name, x is the input, and the output is y, or f at x is equal to the output. So it says in stars, brackets here do not mean to multiply. So we want to make sure that you're understanding that. So here, x is the input, f is the name, y is the output. For ht equals h, t is the input, h is the name of the function, and the output is h, etc. So you have seen function notation for specific functions, but you just didn't know it. So when you have cos theta, cos is the name of the function. The name is cosine. The input is theta. Remember, when you're taking cosine or tan, you always need an input. In this case, theta, which is common variable that we use for angles. So sine inverse 0.5. So the name of the function is sine inverse. The input is 0.5. Because they're giving me a specific value for the input, I could figure out what the output is. So the output is sine inverse of 0.5, which is equal to 30 degrees. Okay, the name is cube root. The function that you're doing to 9 is cube rooting. The input is 9, and the output you're getting is cube root 9, which is equal to approximately 2.08. Okay, so the name is squared. So the function that you're doing, you're squaring. And the input is 2x, and the output is bracket 2x, bracket squared. And so the exponent 2 goes on to the coefficient and also the variable. So number 5. So there are certain things wrong with these. So you can't just take cos. You have to take cos of something. You're missing the input. You have cos theta equals 1 over 2. That way you can get theta by itself by taking cos inverse of both sides. Tan x equals 0.5234 is fine, but you can't have x equals 0.5234 tan inverse like that. You have to make sure you're taking tan inverse of something. And so the tan inverse, the order matters. The tan inverse should be written before 0.5234, so you can take the tan inverse of 0.5234, and you can find what the value is. Okay. Number 6. So you have a Pythagorean theorem. They're saying to put one side as output and hypotenuse as input. So when you're given a question like that, it's easy if you clearly identify what the input and the output is. Generally, what we're going to do is we're going to isolate for the output, meaning we always try to get the output by itself. Similar to how we have, let's say, y equals mx plus b, and we usually have y by itself. And we get the output based on what the input is. And so they said, in this case, output is A, and so I'm going to algebraically do BEDMAS backwards until I get A by itself. And so I'll do A squared equals, move that B squared to the other side, so I'm going to subtract. So A squared equals C squared minus B squared. I have A squared, I want to get rid of the squaring, so I'm going to take square root of both sides. Remember, when you take square root of both sides, you have a positive and a negative answer. So I'm going to write it separately because remember that you need to have, these are functions, so you have to be writing it in function notation. And so you're going to write it separately and say it in terms of the name and then the input. We have the name, which is A. And then we have the input, which we're putting in as c. So a at c equals square root of c squared minus b squared, or a at c equals negative square root of c squared minus b squared. 7. What could be confusing when using function notations? Brackets may or may not mean to multiply. So for this case, we have m 3 minus n. So in this case, the m is a 2 and the n is 6. So if I plug it in just as is, well, I'm just multiplying. Because in this case, m is not a function. M is just a number. So I'm multiplying, and then you should be simplifying. For b, well, they're telling you that m at x is equal to x squared. That is a function. You have to do something to the x. And so I'm going to write m at 3 minus n. So they're telling you in this case that 3 is the input of m at x. So you're going to put the 3 into the x squared formula equation. And so you get bracket 3 bracket squared minus the 6. And you get 9 minus 6 equals 3. So brackets do not mean multiply since m is a function. In this case, m was a function and was not a number. Okay, find the following for the following function. So you have these 3 different functions. So you can tell already that it's useful to not just have y equals y equals y equals. So then I can have these like 3 distinguished functions. So when you have f at 2, what it's telling you is that you're going to replace that x value to a 2 every time you see an x. And the easiest way to do that is with brackets and put in that input. So f at 2 equals 2 bracket 2 to the 4 minus 3 bracket 2 to the exponent 2. And then it's a matter of doing bin mass. And so f at 2 equals 20. So what that really means is that x equals 20, y is 20, which you can write as a coordinate. B, again, you're plugging in 69 every time you see the input of a equals 69. So 69 minus 5 is 64. Square root of 64 is 8. So h at 69 is equal to 8. So you do this repeatedly. Let's say you go to E. Okay, so that 2 is staying like as a coefficient. And then at g at 1 over 2, you're going to plug in 1 over 2 every within the g function. You're going to multiply that to the function f at negative 1. And then basically you're plugging in negative 1 every time you see x. And then once everything's plugged in, like the first line is probably the hardest, just plugging it in correctly. And then you're simplifying. And so the answer to that was negative 4. Okay. So make sure you go through these kind of questions and you're able to get these respective answers. Number 9, let's see. So main idea is, let's say for this question, okay, so first step is let's get y by itself. So it says isolate the output variable and record the answer in function notation. We want to get y by itself. So instead of me replacing y as f at x, let's just be consistent. So I have 2x minus 6y equals 18. I want 6y, the negative 6y by itself. So I move the 2x to the right side, so it's negative 2x. So I have negative 6y equals 18 minus 2x. I want to divide every term by negative 6. So I get y equals negative 3 plus 1 over 3x. So I just need to switch it to function notation. The function name will be f, and then the input is x. So f at x equals negative 3 plus x over 3. So these other questions are very similar. So in this case, you have to remember that you want to, again, get y by itself. And so first we needed to cross multiply. And then we wanted to get y to one side. We common factored y out so that y will appear once. And once we were able to get y by itself, you're going to just replace it to function notation. Okay, make sure you're getting these other answers. So ones that are tough, let's say number 10, they're telling you that for number 10, the perimeter is the input and the length is the output. So you're going to get L by itself because remember, you want to get the output by itself. So we're going to do that algebraically. So we get P minus 2W divided by 2 on both sides. So L equals P minus 2W divided by 2. we're going to write it in function notation. So L at P equals P minus 2W divided by 2. Or another version of this is L at P equals P over 2 minus W. So you can see that it's helpful to know what the input is, because in this case, there were multiple variables. There was a W and the P. We needed to know what we were inputting in. Okay, number 12. Okay, 12 is a little tough. Write down the area of a circle as a function of its perimeter. So you have the perimeter formula for a circle. You have the area formula for a circle. But you need to write area in terms of perimeter. That means you need to work with the perimeter formula, but you notice that P never appears in the area formula. But you do notice that R appears in both. So if we get R by itself, we're able to get R by itself within the perimeter formula. We can sub that into the original area formula, and we'll get area equals P squared divided by 4 pi. So basically, our goal was to only get A's and P's in one equation. And then in our case, we got A in terms of P. And then C and 11 is just further kind of practice for these questions.